it would show you, oops, where is it? Sorry about that. It would show you this. Probability x is less than or equal to 3. The probability x is greater than 3 would be 1 minus that. The probability x is equal to 3 would be the 0.312. And so another is to come in here, put in a value of x equals 3, and look at the results down here. Now you'll notice down here in statistics gives us the probability equal to, it gives us the probability less than or equal to, there's that cumulative probability, and it gives us the greater than probability. So it gives us a little bit of flexibility. And so regardless of what approach, and again, I would advise you not to use the formula. If you use the cumulative tables or if you use statistics, which is what I'm going to recommend you use, you got to get clever. Get clever with the way you try to find these probabilities. So here's what I'm going to leave you with. Look at an example. Before I do that, let me tell you two more things. First, when you calculate a mean, I gave you a formula earlier. The mean of a discrete random variable is the sum of the x's times the probabilities. We looked at that in an earlier video. When you're working with a binomial, you just multiply n times p. I didn't even mention the standard deviation before because the formula is really kind of difficult to use a calculator to calculate. But the standard deviation when you're working with a binomial is real easy. So finding means and standard deviations when you're working with binomial probability distributions is simple. You've already identified n times p, or I'm sorry, you've already identified n, you've already identified the probability of success p, you just multiply them together. So if I'm flipping 5 coins, what's the chance that I get a, or how many of those 5 coins do I expect to be a tail? That's the way I would say it with the mean. What's the expected value? How many do I expect to be tails? I would take the 5 times the 0.3, I'd say 1.5. And that's not right, not 0.3, where'd that come from? I'd take the 5 times the 0.5, it'd be 2.5. I'd expect 2.5 of the flips to be tails. And again, we've talked about expected values before, right? We said that's not what's going to happen on a single outcome, but that's what would happen if I flip coins over and over and over again. Sometimes I'd get 2 tails, sometimes I'd get 3, maybe 4, maybe 1, maybe 2, maybe 3, maybe 0, maybe 5, maybe 2, maybe, if I average up all those numbers, it'd be 2.5. The standard deviation, it's n times p times q. Another way of thinking about this, n times p times 1 minus p, or q. And then you take the square root of it. We'd expect most things to fall within 2 standard deviations in a mean. And so you get a pretty good idea. Just knowing you have a binomial, just identifying that you have a binomial, you have a pretty good idea of where things should fall. All right, so what I'm going to leave you with, I forgot about this slide. Let's go here. What I'm going to leave you with is an example. And this is what I want you to practice. I want you to try this example, and then when we get back together again, we'll go through it and make sure you're doing it right. You're a telemarketer selling service contracts for Macy's. You believe the chance of making a sale to any one customer is 50%. Boy, that sounds like a probability, huh? If you call 20 people, that sounds like an N. What's the probability of making exactly 6 sales? At most 6 sales, or at least 6 sales. Obviously 6 kind of an important number here. Okay, so what I want you to do is to go through and try to figure these answers. That's the statistics printout that I generated. I went in, I got a value of x. Again, watch the video on how you generate this probability functions output. I went in and used a value of 6. N is 20, P is 0.5. I used a value of 6, and I got some probabilities here. Now, use those to answer these questions. It's not real difficult. Once you identify that you have a binomial, that's the toughest part. So go through and see if you can do that, and when we get back together again, I'll make sure you did it correctly. So long.